Right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it for today. This is solving rational equations 1, as in there's like a 1 and a 2. The 2 is going to be harder. We're starting with the easy one today, and then next time we'll do the harder one. So if you're not very fond of fractions, then you might like what we're doing here because we're going to get rid of them as soon as possible. That's like the main strategy whenever you have equations with fractions in them, is to get rid of the fractions as soon as possible. Unless you really like solving fractions that don't have the same denominator, which I don't know if anybody does. If you do, let me know in the comments because I think you're weird. Um, we're going to solve these by getting rid of the denominator as soon as we can, as soon as it's like possible to do so. And that's the strategy. And then once we do that, we solve what's left over. So whenever you're stuck trying to figure out what to multiply, because a lot of times they'll say, oh, you have to find the LCM, right? Find the LCM, which is the least, I don't know why I decided to write that in cursive, least common multiple. Okay, so the least common multiple is the magic number or expression that you can multiply on both sides and get rid of all the fractions all at once. So sometimes it's not really easy to find that thing. Sometimes it is. In this case, the least common multiple for number 1, that is 3m squared. But even if you didn't know that, it's not the end of the world, because what if I just multiplied both sides by m squared? Okay, well, then the m squareds here would cancel. I'd have 3. The m squareds here would cancel with that one and this one with this one as well. So I'd have m minus 4 over 3 plus 2 over 3. Okay, that just means I'm not done yet. So what I'm saying here is it's not the end of the world if you don't find the LCM. Okay, if you've been getting stuck on that, I can tell you that it's not the end of the world. It just means it takes a little bit longer to get all the fractions to go away. But all you have to do is just pick out one denominator at a time. Probably start with the biggest one, because actually if you started with the biggest denominator, then 3m squared would be the biggest one, and then if you multiply both sides by that, that would have been the LCM anyways. So when in doubt, just multiply both sides by the biggest denominator, and if that's not the least common multiple, you can just multiply again. So I can just multiply again. Now I have to multiply this 3. I have to multiply both sides evenly. That's the other mistake I see, is that people try to just multiply the fraction stuff to get rid of the fractions. Well, it's like, yeah, that's like why we're doing this, but it's an equation, so it has to stay balanced. So you have to do everything to both sides evenly. So 3 times 3 is 9. Here, the 3's are all going to cancel, right? So m minus 4 plus 2. And then we just have a little equation to solve. So minus 4 plus 2, that's just minus 2. 9 equals m minus 2. Add 2 to both sides. And we get m equals 11. Okay, and if I go a little fast with these equations and solving them, it's probably just because I've spent a lot of these former videos, Algebra 1, Kuta software worksheet videos, solving equations, simplifying expressions, that sort of thing. So since I've already done a lot of that in previous videos in this same playlist, then at the end of these videos, there's a link to that playlist and a link to any video that I might think is helpful as like a supplement, or like a, hey, maybe I need to go back and check how to like solve things kind of video. So you can always go to the end of this video at any time and click on that playlist and go check it out. All right, so for number 2, I've got this and this, and like I was saying before, if you multiply both sides by 5n, and I apologize for a little sniffle. I think I'm coming down with a small cold, so I have to excuse my voice. It probably sounds a little off today. The n's here cancel, so I just have 5. It's 5 times 1, which is 5. The 5 ends cancel on the right side all around. So I have 1 minus, ooh, careful, 1 minus the quantity in minus 1. Now, I didn't have to have a parentheses around the n minus 1 because it was grouped by the fraction. But if I get rid of the fraction, I still have to group it. Right? This is kind of like it has a parentheses around it, low key, because it's a fraction and because it is all over that 5n that got canceled out. So we have to be really careful there. That problem, number 2 here, this would probably stump a lot of people that are in algebra doing this, but not you, because you have now seen their ways and avoided their schemes. Okay, so 5 equals 2 minus n, and then we actually want to, this is tricky, we want to subtract 2 on both sides. So I'm going to rewrite this over here, actually. We want to subtract 2 on both sides. So you might be thinking, well, wouldn't I just do the opposite of the sign in between? And that's sometimes right, but not necessarily. This is tricky because when the sign in between is plus or minus, the letter and the number, the sign in between is a plus or minus, that just means that I'll either be doing plus or minus that number to both sides. So that's what that means. So if I have 5 equals 2 minus n, that just means I'll be adding or subtracting the 2. I need to do the opposite of 2, though. The opposite of 2 is minus 2. That minus belongs to the n. So I get 3 equals negative n, which means that n equals negative 3. Whew, all right. So let's keep going here. And again, I apologize for the sniffles. It might also just be allergies, because I live in Florida, and Florida is just a crazy place for allergies. So it could just be that. So remember the little trick about if you don't know what the least common multiple is, which, spoiler, it's 6x squared. If you didn't know, a lot of times if you choose the biggest thing, that ends up being the LCM. So 6x squared, 6x squared. 6x squared and 3x squared, if I divide those, the x squareds would go away. 6 divided by 3 is 2. And then I'm just multiplying by 1 on the top here. So 2 times 1 is 2. Okay. Here this is a little different because now the denominators of these two things are different. So stuff that cancels is a little different. The x squareds still cancel all around. So that's a thing. But here it's 6 over 2, which is 3. 6 divided by 2 is 3. And then I still have to multiply 3 by the quantity x plus 3. Be really careful. Anytime there is more than one thing in the numerator, you have to wrap a parentheses around it and distribute the stuff, the leftover stuff, if there is any. Which, speaking of, here there's not in this other one, because it's 6x squared divided by 6x squared, which is 1, but I still have to put minus 1 there. All right, so then I distribute 3x plus 9 minus 1, 3x plus 8. I'm going to, well, first I'm going to make a little division here, a little bar, not to be confused with mathematical division. And I'm going to subtract 8 from both sides, so I would get negative 6. And then divide by 3 on both sides and get negative 2. All right, on to the next thing. Boom, 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 boom. N squared is the biggest thing, and it also happens to be the LCM. Cancels, cancels. I get 4 equals. Here that's just going to be n. So n times 5 is 5n. And then the n squareds here cancel. So it's just minus 1. So I add 1 to both sides. Divide by 5. Then I get the answer. Put another little division right here, because it kind of looks like that answer is part of number 4, but it's part of number 3. All right. So number 5. And if you've noticed a trend here, it seems like whatever the biggest thing is, that happens to be the LCM. Okay, so that goes away, that goes away. 3n plus 15. I didn't need to put that in parentheses because the 4n squared cancels complete with the 4n squared. So there's nothing to distribute. Right? So 4n squared, n squared, I have 4 times 1 is 4. Minus 4n squareds cancel out completely here. But it's a minus. So I have to distribute. Sorry, I got distracted because it's raining outside, I think. It's Florida never ceases to amaze. 3n plus 15. 4 minus, now I have to distribute, minus n plus 3. Okay. I want to add n to both sides. That would get rid of the n here. And then I want to, well, let's do this. Not too many steps at once here. 4 plus 3 is 7. And then I would subtract 15 from both sides. So 4n equals negative 8. And then n equals negative 2. All right. And again, if I'm going a little too fast with solving these equations, it's only because we've solved equations like this in previous videos in this same series on Algebra 1 worksheets. Right? This is a series on Algebra 1 and worksheets. So I've already done videos that go in more detail about how to solve equations and go a lot more step by step. So again, if you're getting a little lost on that, if I'm going too fast on there, I apologize. You can check out those other videos on how to solve equations. This video is focused on how to get rid of the denominator and then of course solve it. Not focused on the how do I solve after I get rid of the denominator. All right, so looks like 2n squared is the winner here. 2n squared. And again, if it wasn't, it wouldn't matter that much. You just kind of pick something, go with it, and if it didn't get rid of everything, that's fine. Just do it again, like I showed you in number 1. The 2n squareds would cancel here, so I'd have 1 left. The 2n here would cancel with 2n, and I'd have 1 more n left over, so plus 5n. And then here I have the n squareds cancel, so I have 2 left over. Want to distribute that 2. 2n minus 4. Subtract 2n on both sides. Subtract 1 on both sides. Ooh, this is not working out well. Let's see if maybe I missed something, because every other answer has been nice so far. 1, 2n, 2n squared, so n, 5n. 2n squared, n squared, 2, 2n minus 4. 3n, we're subtracting 1. Yeah. Okay, that's kind of weird. I'm getting negative 5/3, so I don't know. Maybe I am doing something wrong. Let me know if I did. But I'm gonna check because I don't like that answer. Okay, it is negative 5/3. Oh my gosh, it's so weird. You feel like you're doing something wrong because all the other answers so far have been positive or negative whole numbers. So that was kind of weird. Okay, I mean it is possible, but that brings up a good point. To be a little general here, if you get an answer that's like a fraction or decimal or something, when all you've ever been getting so far are positive or negative whole numbers, that's a red flag. You got to check that. In this case, it didn't turn out to be like the wrong answer, but it's still a red flag. You got to check that because a lot of times, especially when teachers write tests, if they want you to have all nice answers like positive or negative whole numbers, then they usually stick with that theme throughout the test, and they hardly ever deviate from that. So what you would want to do then is if you get a negative or not a negative, a fraction or a decimal, you'd want to check it to make sure it's good. Make sure it's legit. Okay, I'm going to do a new thing on number 7 here. I'm going to just wrap parentheses around everything. This is a little bit lazy, mind you, and it's not technically mathematically how you're supposed to do it, but I think you can kind of see what I'm getting at here. I'm multiplying everything by x. Okay, so I'm wrapping, excuse me, the whole thing the whole equation up in a parentheses and multiplying it by x. All right, so the x's cancel here. And, excuse me, and I still need to distribute that x to the 1, so I need to not forget to do that. But I have x minus 6, x plus 4, and x. Okay, well, the x's cancel here. Oh, no, they don't. Excuse me. Man, allergies are crazy. I think it's like sometimes the rain stirs up the pollen in the air. So, again, I apologize. Let's see if I can get rid of this right here. Put an x there. All right. 2x plus 4. I'm going to subtract x from both sides. I'm going to subtract 4 from both sides. And then I'm done, actually. Because when I subtracted that x from both sides, it gave me just x by itself. All right. So we want to multiply everything here by 4n squared. So 4n squared divided by 2n. 4 over 2 is 2. N squared divided by n would be n. Times 1 is that thing. Next. 4n squared cancel completely, and I just have 1. And then lastly, after the equals, 4 divided by 4, that goes away. N squared divided by n is n. So I just have this. I would subtract n from both sides and subtract 1 from both sides and get n equals negative 1. All right, so that one actually wasn't that bad. Okay. Let's do b squared. So b squareds cancel. This b will cancel as well, and it'll have 1 left over. But this is just 6b plus 18, because that fully canceled, so there's nothing to distribute. Then b squared divided by b is b, because b squared is like, b times b. So one of the b's goes away. And then b times 1 is b. So I just have that. Equals b squared and b. Cancel 1 for 1, so I have 3b. All right, lots of b's. So 6b plus b is 7b. Plus 18, 3b. I want to subtract 3b from both sides. I want to subtract 18 from both sides. That cancels, that cancels. 4b equals negative 18. Divide by 4. Divide by 4. This is another not so nice answer. Goodness gracious. Negative 9 halves. Excuse me. So let's go ahead and look at this one, because again, it's a fraction. We did just get a fraction not that long ago, but it is kind of weird, so let's go ahead and check it. Number 9. Yeah, negative 9 halves. Okay, and spoiler alert, number 10 is 1/6. Ha ha ha, I looked ahead. Okay. So let's go ahead and do this. We have, and as we go along, I start to go a little bit faster, or at least that's my aim, because, one, I don't want to bore you if you're starting to get it, and you're like, okay, like I know how to kind of do this. I just, want to get to the harder questions now. Well, you're always welcome to skip ahead in the video, for one. I promise I won't be offended. I hardly ever look at the stats of the videos, so you can always do that. Or you can double speed it if you want. But I will start to go faster as we go along, unless we come up to something new, and then we'll figure it out from there. So this is going to be x squared. Just x. 2x squared divided by 2x. There's an x left over. Minus 2x squared cancels, but I still have to make sure I put that in parentheses because I have to distribute that negative. Careful with those negatives. Not a lot cancels, just the x. So I'd have 2x left, and then times that by 3. So x minus x plus 1 equals 6x. X minus x goes away. That's 0. And then we would divide by 6. And we got that 1/6 answer that we already knew about because we looked ahead. Couldn't help it. Looked ahead a little bit there. Okay, so this is kind of new. This looks a little daunting. The trick to this, and we actually can't use the trick that I mentioned earlier. The trick from earlier was, hey, just multiply by something, and then the other thing will go away. Well, since we have what's called a trinomial and a binomial, it is very possible, very likely, that one of the factors of b squared minus 7b plus 10 is b minus 2. It's pretty likely. And since that's the case, we have to factor out the trinomial and figure out if one of the factors is b minus 2. Now, you could always get away with that using basically the same logic that we did before, like, hey, just multiply by the biggest thing. So we'd multiply all three things here on both sides of the equation by b squared minus 7b plus 10, and then by b minus 2. So if you're not that great at factoring, you could do it the long way and do kind of what we talked about earlier. Okay, multiply everything by b squared minus 7b plus 10, b squared minus 7b plus 10. Okay, that would cancel there. That cancels there. And then we don't know, if we don't factor, what cancels and what doesn't cancel. So we would say, okay, b squared minus 7b plus 10 over b minus 2. Because we didn't get rid of the b minus 2. We kind of did, because b squared minus 7b plus 10 does have a factor of b minus 2. But if you didn't know how to factor that well, which is fairly common, actually, because factoring turns out is hard, and if you're not that great at it, because it's hard, so a lot of people aren't, then you could always just say, okay, well, b minus 2 is there. Let's just multiply by everything by b minus 2 now. Okay, you'll end up with more stuff, which is the trade-off, but at least you can still get rid of the denominator without having to know how to factor. Okay, so then this would be 2 times b minus 2, which is 2b minus 4. And then we, put stuff together here. So, let's see. We would have, trying to think how to best do this, because if we had done it the other way, it would have been a lot faster. But let's just go for it. So, b squared. The b's, if I put those together, minus 6b. If I put the numbers together, I get plus 8. 2b minus 4. Okay. And since we have a b squared, okay, so actually it turns out we can't really get away from factoring, because since we have a b squared and a b, we can't solve it using SADMEP. We can't solve it using standard, solving procedures and whatnot, right? So we would like to, but we cannot. We have to factor it. We have to get everything on one side. We have to set it equal to 0, and we have to factor it. Now, we could have factored in the beginning, and it would have saved us time, but we would have to factor now. So it looks like this method is not actually maybe the best method, because you have to factor either way. Minus 8b, that's minus 4, so it would be plus 12 equals 0. And then we need factors of 12. That give us 8. So it looks like 6 and 2. 6 and 2. Minus. Okay. And we get 0. Now, this video is not intended to teach you how to factor. So if you're like, wait, what? How are you factoring right now? If you're not cool with factoring, I have like a whole nother series on how to factor. And it's one of my older series. I think it's like the very first series I ever did. It was a series on factoring. So you can definitely go check those videos out. Those are on my channel. It's under factoring series, I think is what I called it. So you can check those out as well. But yeah, so this video again is like, the focus here is to get rid of the denominators, not to show how to solve an equation or to factor. So it looks like here we would get either 2 or 6. But if I were to plug in 2, it wouldn't work, because look at this. b minus 2. That's what's called an extraneous solution. They call that an extraneous solution in the textbook. Sounds very fancy. But it basically just means, hey, you didn't do anything wrong, but you kind of did. You did all the right things, but you got one of the wrong answers. It's this weird, like, oxymoron type deal where we didn't do any math wrong. We got b equals 2 and b equals 6 by doing all the right math, but one of the answers just happened to not work out. Just didn't work out. So only 6 was the correct answer there. Okay. So if you are trying to do this the kind of the way where you don't figure out what the LCM is, it kind of bites you in the butt. So let's go ahead and figure out what the LCM is. Okay, it's the least common multiple. So we do that by factoring. Okay, let's make a little divider here. A little divider. So x, if I take out a factor of x here, I get x minus 3. So then I can see, oh hey, x times x minus 3 is the LCM. It's the biggest thing, and it includes this x minus 3 thing here. And of course, this is the same thing as this. So this then is the LCM. We multiply both sides by the LCM, and then stuff cancels. Okay, so if we multiply both sides by x squared minus 3x, or you could say x parentheses x minus 3 parentheses, that all goes away. So we just have 1. Then next, only the x minus 3's would cancel, and I would have x left. Next, the whole thing cancels, and I would have 3. See how much easier of an equation this is to solve? Maybe I'll show you, if we have time, on number 11, how it would have gone if I had done it this way, like we're doing on number 12. But probably not. I'll probably just keep it that way. Number 11 will be a scar amongst the canvas of this mathematical work. All right. So this, number 13, we need to figure out what the LCM is. So we do that by factoring. At least now we do. And it looks like it's p times p minus 5. P times p minus 5 is all of what that last thing is, that last denominator. And it's made up of 2 parts in which we already have in the previous denominators. So if we multiply by p and p minus 5, it covers all our bases. So here, the p's cancel. Right, so we just have 6 times p minus 5. Then here the p minus 5's cancel. The p is still there though. And then here everything cancels. But it's still minus, so I have to distribute that minus. Okay, so this is 6p minus 30 equals p minus 4. P's cancel. 6p equals, we'd have to add 30 to both sides, so 26. Ooh, we're not getting a good answer again. Hold on. I really don't like not getting a nice answer, because most of the answers here are positive or negative whole numbers. So at this point, I'm kind of like, well, I probably did everything right, but what if I didn't? What if I done messed up, Aaron? So I need to go check that out. Let's go look. See if I messed something up here. 13 should be 13 over 3. Yeah, it is. All right, weird. Let's go ahead and look ahead to these other answers here. So it looks like we get a weird fraction here, a weird fraction here, a weird fraction for 17 and 18. All right, so we're getting a bunch of just weird answers here. Okay, so hopefully now that we've looked at all of the answers all at once, we won't try to cheat and be like, oh, we already know the answer. So because likely your professor or teacher or whatever is going to be like, hey, show your work, because I know you could look it up and get the answers, so it's not good enough to have the answers, and that's why you're here. Hopefully. I don't know. Maybe. So we need to factor. Factoring first is much better than factoring later, as we can tell with number 11, which took up like the space of 3 different problems. So when we factor, we want two numbers that multiply to the last number. Now there's 1 and 18. That would work. 2 and 9, or 3 and 6. But those numbers need to add or subtract to 9. In this case, they need to add because 18 is positive, so its factors would have to be either positive, positive, or negative, negative. I need them to be negative, negative. So, like this. Right? Negative 1, negative 18. If I added those together, it would be negative 19. But I need to get negative 9. Right? Negative 2, negative 9. No, because that adds to negative 11. Negative 3, negative 6. Yes, because that adds to negative 9. Right, so that was kind of the whole basis of a whole series on factoring that I did. And if you look here, x minus 6, x minus 6. There we go. And it looks like these two denominators here are the same. So we multiply everything by x minus 3, x minus 6. Okay, so all of this would cancel. All of that would cancel. And a little bit of this would cancel, and we would have x minus 3 left over. So I'd have 5x minus 20 plus x minus 3 equals x minus 4. All right, that actually wasn't that bad. So then we have 5x plus x is 6x, negative 20, negative 3, negative 23. We want to subtract x from both sides, add 23 to both sides, so that's going to be 19. And then we divide both sides by 5. 19 fifths is the answer. All right, on to the next one. And we're actually almost done because we're getting like harder and harder questions here. So if you look, we've got 6 more. That's not bad. All right, so let's go ahead and figure out what the LCM is. It looks like it's going to be, if we take out k, 5k plus 2. Oh, there we go. So it's k, 5k plus 2. So we want to multiply that. That's the LCM. We want to multiply the LCM all around to everything. And we have 1 minus 6 parentheses because there's a k. We don't really need the parentheses necessarily, but we might have, and we might in the future, equals 6. So we would get negative 6k equals 5. K equals negative 5 over 6. So notice the pattern here so far is that when we factor, one of the factors is the other thing. So just, if you notice a pattern, then you're like, okay, like I should expect this to happen every time. And if it doesn't necessarily mean something's wrong. It just means you probably want to check your work because, that pattern just broke. So you're like, hey, what's going on? All right, so 8 is 1 times 8, or 2 times 4, which is more helpful because negative 2 and negative 4 add up to negative 6. Boom, 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 boom. And look at that, n minus 4. So the LCM is this. So we want to multiply everything by the LCM. This is going to cancel completely, so 6. This cancels completely, just like the other one. Minus, the n minus 4 would cancel with the n minus 4. Then I would have n minus 2, but I have to put parentheses n minus 2 because I'm distributing a negative. 6 equals 1 minus 2, 1 minus n plus 2. 6 equals negative n plus 3. Excuse me. I would subtract 3 from both sides. And then multiply both sides by a negative 1. All right. Now we're on to the red. This one's going to be pretty straightforward. We would just factor out an a. So it looks like that's the LCM. Boom, boom. Multiply both sides by the LCM. A cancels with a, and I'd have 4 times the quantity a plus 4 equals. These denominators are the same, so they cancel with the LCM. So it's just 1 minus the quantity a plus 3. It's This is 4a plus 16 equals 1 minus a minus 3. I'm going to add a to both sides. I'm going to subtract 16. Now, it's 1 minus 3, which is negative 2. 1 minus 3 is negative 2. And then I'd be subtracting 16, so negative 18. Then I divide both sides by 5. So negative 18 fifths. Then for this one, 6, 1 and 6. Oh, that doesn't work. Or how about 2 and 3? Yeah, that works. K plus 3, K plus 2. And that works because I have the K plus 3 right there. And my computer's yelling at me to plug it in. There we go. So that's the LCM. Come on. There we go. LCM. So these guys cancel completely. 3 minus the quantity k minus 6 equals 1. The k plus 3's cancel, and I have k plus 2. Not really anything to distribute there, but I figured I'd just show you what that looks like, right? Because you usually always have something to distribute, unless it's a 1 or there's a negative. Well, the negative you would distribute as well, but man, allergies suck. Whew. If you have allergies and you guys are thinking about moving to Florida, think again. Florida is terrible for allergies. Minus k, and then plus 6. K plus 2. All right, so then we would, we need some more space here. So we're going to add k to both sides. So we'd have 2k. 3 plus 6 is 9. Minus 2 is 7. Divide by 2, divide by 2. 7 abs. All right, and then the last one, or the last two, we have v plus 3. So that's our LCM. Multiply both sides by the LCM. V plus 3's cancel because it cancels completely with the LCM since it is the LCM. So we have v minus 3 equals v minus 5. V minus 3 equals v minus v plus 5. V minus v is 0. And then we just add 3 to both sides. V equals 8. I thought that one was a fraction. Oh, no, it wasn't. The last two are not fractions. The previous two were fractions. The last two are not fractions. That's right. Let's see. So m plus 3. I feel like this is not as hard as some of the other ones. I don't know why they're ending on an easy note. Maybe they wanted to end on a lighter note. All right, so m plus 3. 3 plus 3m. And we would subtract m on both sides, so 2m. Subtract 3 on both sides, you get 0. So then m is equal to 0. I do remember that. And there we go. So this has been part 1 of solving rational equations. Start from the top here and kind of scroll down slowly from the top. But solving rational equations 1, excuse me, which is the easy part. That's the easy part. This is the easier version. So next week or sooner, we'll tackle the harder version of this. If you can imagine, if you thought this was hard, it does get harder. I'm sorry to say, but you know, in math, things can always get harder. So that's just how math is. It can always make it worse. But depending on your teacher, they might make it worse or just keep it like this, or who knows. But we will be tackling that worksheet next time, so stay tuned for that. And after this scrolls past these last couple here, it'll show you the answers. You can also look up the answers yourself just by Googling the name of the worksheet. It'll come right up. Otherwise, it's here. And if you haven't gotten my free guide, it's called The 5 Math Mistakes Everyone Makes and How to Avoid Them. It's free on my website, myersmathematics.com, and the link for that is in the description below, along with some other helpful links as well, like if you're looking for online tutoring or anything like that. I have a first free lesson, 1 hour lesson for free that you can take advantage of if you would like. If you just need 1 hour, then hey, take advantage of that for free. You can sign up using a link for that as well. All right, and that's everything I have to say. And if you had anything else you wanted to say, if you had any questions, comments, or concerns, leave those in the comments below, and I'll get around to them as soon as I can. And I'll see you guys in another